Measuring the amount of light is interesting, but let's step it up a notch and look at something even more complicated. What I have here is the TCS34725. What's that? It's an RGB sensor. With this little sensor, or breakout board, I can actually measure color. And I can take that measurement and apply it to an output. And we'll look at that a little bit later on in the video. But first, let's hook it up and just see what serial communication data I can get out of this breakout board. Again, like many other sensors, it's very easy to hook up through I2C. It's 4 wires: power, ground, SDA, and SCL. I'm going to start by plugging it in right here and grabbing a few wires. Use a few long ones for power and the yellow and orange I always like to use. So first thing, power. Right here, 3.3 volts. Ground. Right next to it. Put that into the ground pin. Oh, and you can already see I've got some power in here, so shame on me. You should never wire anything up when your Arduino's plugged in. Let me unplug that. And that light is used to illuminate objects that you're trying to sense the color from. Next, we'll take a look at the data pin, which should say SDA. There it is. And that gets connected to analog 4. And SCL, the clock. There it is. And that goes to analog 5. Now that should be just about hooked up. Let's load the library and take a look at what happens. Now while that's uploading, we'll talk a few more things about the sensor. First being that it has a built-in temperature sensor. The other thing is that it reads RGB color plus clear light, and it has an IR blocking filter. This is not for looking at infrared. If you want infrared light, you can use the IR lux sensors. This is for looking at visible light, something that humans can see. It has a really wide range, and there's several different kinds of color sensors out there. This just happens to be my favorite because it's so easy to use. Now that my Arduino has loaded up, let's go to Include Library. And we can do a quick search of TCS, and as soon as I hit probably, oh, that's all I needed actually. There it is, RGB Color Sense Breakout Board. Let's install it. Let's quit, reload it. Go to the examples, and there it is. So let's do TCS34725. Close that one out. Okay. And let's go ahead and upload this to the board and then talk about the code. I'm going to plug my board in. And both the board and the port are right, and I'm going to upload the code. And we should start to see that blinking. There it is. And we're done. Now if I open up my serial monitor, it says it found the sensor. It actually has some really nice error handling in there. And it's telling me color temperature. That's really handy to have. The lux, and then the RGB value plus the sensor value at the end. So let's grab something, oh, I don't know, yellow. Right now it's saying RGB, let's see, 1200, 1200, 1172. Let's just call it all about 1200. And if I put something yellow in front of it, let's see how that changes. Drastically changes. Now it's like 7,000, 6,000, 3,400. So that's the raw data coming out of this sensor, and it's working pretty well. But to be quite honest with you, it's a little boring. I mean, we can read RGB values, we can read the color temperature. It's kind of neat, and you might have projects that need that. But let's do something a little more interesting. I'm going to challenge you to take a look at the code in the library and other examples and figure out how can I give some feedback using this sensor. So go ahead and pause the video here, and we'll pick up in a minute. All right, have you figured out what to do? Well, if you go through the library, specifically if you go into examples, TCS34725, and you look at ColorView, that's what I have open right here. And what that enables you to do is hold up any object, let's just say the end of this screwdriver, over the sensor. It reads the color, and then it sends out through 3 pins information to light up an RGB LED. So what's an RGB LED? It's pretty simple. It's a common anode, so that means the longest pin, which is pin 1, is connected to 5 volts, and then there's basically 3 LEDs built in here, a red, a green, and a blue. So pin 1 is the long one. To the right of that is pin 2, believe it or not, then 3 and 4. Let me draw a quick diagram to show you how it works. We'll wire it up and take a look. This makes the sensor a lot of fun. So basically you have your LED, and it looks like this. You have 4 wires coming out of it. One of them's longer. This is pin 1. Pin 2 is here, 3 and 4. I know it's a little strange that they're numbered that way, but that's just how it is. That's where it's a good lesson to always read your data sheet. Pin 1 is connected to positive 5 volt. It's a common anode or common positive. Pin 2 is connected to red. That's the red LED, and that's going to go to pin 4. Pin 3 is connected to the green LED. That's connected to pin 5. And this is blue. And that's connected to pin 6. Now, this is a common anode of 5 volts, so we actually need to add resistors here because the LEDs have different voltage requirements and it can't work off of 5 volts typically. So red is going to get in line a 560 ohm resistor. Green is going to get a 1K ohm resistor right here. And blue is also going to get a 560 ohm resistor. Just like you would hook up a normal LED, except for this is 3 little LEDs in one package. So let's go ahead and hook that up. I'll grab my board here again. And here's that LED. Remember, pin 1 is that extra long one. I'm going to put that long one right in there. And if you kind of just take your time and get into a breadboard, it will go in pretty easily. And the first thing I like to do is connect up that common anode because I want to make sure that's in the right spot. See, that long one right there is going to go to the 5 volt. Now I can cheat on this one a little bit, right? There's the 5 volt power to the board right here. And if I just jump it along any one of those pins along that rail there, I'm good. And now I'm going to connect up the 3 individual LEDs. So I have 3 resistors right here. I have 2 of the 560 and a 1K. So if you remember from that diagram, the red is going to be connected to a 560K resistor to ground. So what I like to do is I'm going to go ahead and jump the gutter to a rail over here, and that way they're not connected. Works for me. I have another 560 here, and the other 560K resistor is going to be connected to the blue. So that's the bottom pin right here. Actually bend them out of the way a little bit. And then pin 3, which is between the power and the blue, gets a 1K resistor. So that should go right in here, and I think I might even be off one row there. There we go. That looks right. Okay, now all we have to do is wire up the individual LEDs. We'll start with the blue right here. That goes to pin 6 of the Arduino. Then we can do the next one up is green. That goes to pin 5, followed by red, which goes to pin 3. We'll plug the Arduino in. Make sure our board and port are correct. They are. We'll upload it. Should start to see blinking here. We do. And the LED's on. Let's go test it with something here. We'll start with my infamous multimeter. Let's see if it can read red. Look at that. The LED turns red as it sees red. Let's try a few other things. What else do I have here? Oh, I have a bottle that I printed out. Yep, that turns blue. And what else do we have? A little bit of purple here from a box. Kind of a purpley color, sure. Close, not exact. Maker's notebook. Yep, that's about that blue. And what else could we try? Oh, here's some yellow that we were looking at before. Let's see if the LED can simulate that. I don't know if that's picking up on camera well, but it's actually a pretty good match right there. So that makes this color sensor infinitely more fun. Now there's also more example code in there that allows you to connect it to processing so you can have a color on your computer screen. And really think about all the different things you could use this for sorting materials or really anything in robotics. A lot of fun and very easy to use.